Hello, hi and welcome to this talk on integration platform using open source or integration platform using only open source. This will be a presentation from the trenches. It will be showing you how it's actually done in real life. This will be no presentation of new protocols, new buzzwords, new ways of working or fancy words. So if you're looking for the newest, hottest thing, then actually this might be the wrong presentation. But if you want to see how it's done in real life, then this is for you. What I will show you how is you can build an integration platform using only open source products. But first, what do I mean by integration platform? I mean traditional API gateway management, event streaming, gRPC if needed, message manipulation, and finally, authentication authorization. My name is Magnus Hedner, and I've been working with API for the last 8 years. I'm an engineer. I started programming back in 1978. And this is the story about the third API platform I'm setting up. But before we dig too deep into that, we need to understand where we as a company come from and what the challenge really is. So the first slides are about setting the scene. A few years ago, it was decided in my company, Benify, to invest in an integration layer. How come? To explain that, I have to go a little bit backwards in time. Our system was created 20 years ago. The normal way to build at that time was to build a monolith. Everything, except for database and the outer security layer maybe, was done in one and the same system. Logins, certificate handling, client UI, and so on and so forth. So the system is built as several services all talking to each other in the spaghetti fashion within the monolith. You have the user service, you have the payment service, the benefit service, the order service, the CMS, and so on. And then, of course, you have integration to client systems. But a lot of water has passed under the bridges since the system was originally built. Today, the development is more done in the componentized or cloudified, if I say, environment, and that puts a number of other requirements on the platform. Also, the requirements on integrations are changing. We are now required to do APIs. Soon there will be webhooks, GraphQL maybe, and so on. And when it comes to authorization, we used to do it in one way. Now there are more ways to authorize. And in a monolith, you would need to code all that yourself. And then we want to do client data adaptation outside of that monolith. So we're at the decision point. Did we really want to create all this new functionality ourselves? The capability to integrate is core to our business, but the integration products might not be. And at this point, it was decided to break out the integration layer from our system to separate components. Decision made, but to what? And actually, a side note, do you recognize the left picture? If not, you should go and see the movie 2001: A Space Odyssey. So, some key numbers from our operations. We have about 3 million users, 3,000 suppliers, 1,500 customers, and so on and so forth. The important numbers to me in this is actually the number of customers and suppliers, because that's the ones that use integration layer to communicate with us. For large companies, these communication with the client's human capital management systems are normally made electronically somehow. For smaller companies, we have a file upload in the UI where admins upload an Excel file or so. Error-prone maybe. When Benify started 20 years ago, everything was done by sending files. A client would upload a file to us or download a report from their HR system and send it using SFTP to us. And we would then read the file and update the client list of employees. A new employee would then trigger the setup of a new user. Updates and deletes of employees was also handled this way. An employee registration for benefits, a file was generated with the order and sent to the supplier. Another file was then sent to the employer for the salary deduction, and so on. Fast forward a little bit into time. About 8 years ago, when I started working in the API arena, there was a smaller number of API vendors, and they all had like an API gateway bundled with a developer portal so that you could offer self-registration in the portal to access the APIs. The problem then when starting an API business was to select one supplier of your portal. Then you installed that and you were ready to go. There were REST APIs and Swagger files and some other formats for describing APIs. Then something actually happened. AIs became more complicated, new standards emerged, and thus writing an API became more and more complicated. And more importantly, the suppliers started to bundle their API gateways with more and more solutions to create a complete integration platform. Usually this included an IDE for development, a UI for management, some kind of messaging platform, some means of logging, and so on. But all that came at a cost, some kind of license cost, obviously, but also a cost in that it was suddenly easy to extend your integration platform with the messaging system in the package you already bought. And suddenly you are locked in, and it's hard to change. The recent response to this is called the Great Unbundling. This is the counter reaction where you as a buyer can pick and choose different components from different vendor suppliers and connect them. Lots of great minds have actually written miles about this, starting with Christian Posta in March 23, and then Eric Wild, Mark O'Neill, Christopher Sandoval, among others. But actually, there's a cost also in unbundling. You can't get everything in a neat package. You might have different UIs for different parts. And most importantly, you need to understand how the parts communicate and how you connect it all together. As for the integration components, standards help. So for instance, as we'll see later, communicating between an API gateway and the identity provider can be done using OAuth. Communicating between an integration layer and the backend can be done using APIs plus a JOT bearer token or something else. And there's another thing with this, cost. The theory behind pricing strategies that most companies use is that you start small and then you grow as your consumption increases. Most of these package solutions have different tiers, so you can start at the low level and then you grow. And thereby you take the cost when you've grown into the costume. It's looking good and it's looking fair. I mean, it's fair to pay for what you use, right? The industries I have been working in have a couple of requirements though. You have GDPR, no sensitive data is allowed to leave the organization, and you have high availability. You need to duplicate in 2 data centers and then duplicate in each data center again, because the system has to be hot failover and so on. And this normally drives you in the enterprise unlimited price tier. And especially for CPU-based licensing schemes, this is actually devastating. And on top of that, to my experience, an API uptake of an organization is never as good as you think it will be. So you end up paying for some systems not even making your service warm. Open source to the rescue, right? Well, before we go into the juicy parts, I need to go through briefly the 3 main use cases we see for external access using the APIs in order to set the scene. For this example, we will use our user API, which is actually documented in our developer portal, which is running open source redoc, developer.benify.com. So the first use case is when a client uses our user API unmodified. This is the simplest case. The API gateway does its job and then sends the call to the upstream service. Piece of cake. Second use case, a little bit more interesting, is when the company wants to use some other API. Maybe they cannot translate from their representation to ours. No big deal, we can do the transformation, but that requires another component in our platform, the integration component. And this is the component that translates between representations. This new integration component is also vital for the third use case, namely where we want to reach out to someone to get their user data or to put the data to them in other cases. In this case, the integration component is not triggered by some external call, but by an alarm clock. So, enough with the background, the use cases and all such stuff. So what this all boils down to is we need some external integration, incoming, outgoing API gateway, and SFTP. We have integration tools, low-code tool as data integration layer, and possibly more tools, such as report generators. We have internal integration, which is an internal API gateway and event streaming, also known as PubSub. And on top of this, of course, we do have an identity provider to provide for the security. But actually, there's one more thing before we come into the user part. It's the requirements. What requirements do we have on the components? Well, the technical functionality, or FuncRec, they are the usual. For API gateways, that's throttling, authorization, authentication, routing, logging, and so on. Non-functional requirement, well, the usual. It should be multi-node, Kubernetes adapted, monitoring possibilities should be there, and so on and so forth. Cost, low. What did you think? Active, yes. Preferably, it should be actively supported and developed by someone who also has a paid tier, which you can move to if or when you need. And then we had a fifth requirement. We wanted to have open source. Why? Because we would like to control the build. We would like to make vulnerability scans, follow and update security alerts. We want to rebuild constantly. And actually, it's very good to have the source to look at when something doesn't function as you expect. So the shortlist for these components are, well, not that short if you consider the first four requirements, but the fifth one removes most of the contestants. Now for the juicy parts. Let's start with the API gateway. What made the difference for us was that the product that we chose, which is named API 6, is a proper open source product, released as a project under the Apache umbrella. Hence, the license is the Apache license. This means that this product will not suddenly turn from free to paid, which can happen with some kind of freemium products, in which you have a free product, but only as long as the supplier wants. They can turn the license into a paid-for license at their will. But with a proper open source where you have an Apache-style license, then you know that the source will always be available. I won't go into much more details about API 6, but we are very happy with the free version. It has all the runtime bells and whistles you could accept, and it's pretty easy to extend. For instance, we have created our own integration to the identity provider to cater for our needs. And we are in the process of moving to the standalone deployment mode. API 6 has 3 different deployment modes. And this is removing the need for etcd and API 6 control plane and API 6 UI. This mode of operation is more adapted to the Kubernetes way of working. You start your API 6 pod with a configuration containing all routes, etc. And if the configuration changes, you just spin up a new pod with the new settings. Zero downtime. Actually, the only heavy thing we haven't tried out yet is throttling based on user in a multi-environment. But that is really not crucial to us, as we are throttling more for protecting the upstream than for tiers-based charging. We have created our own tool set as well. For instance, our CI/CD tool. Actually, so far it's manual CI/CD, so it's not really continuous. It's built by ourselves. We have defined our own way of defining and storing configurations, including OpenAPI specs files, and we keep those close to the service. And then this tool walks the source tree, builds the configuration files, and creates a config file that we start the API gateway with, all done in just a couple of 100 lines of Python code. Are there any downsides to this? Yes, of course there are downsides. Mainly on the UI for administration, which is where the suppliers normally differentiate between their free and paid versions. But we are focusing on having all set up done using CI/CD, and we're going full Kubernetes by starting the pod together with its configuration. So then the truth is in the configuration. But there are also other things. Normally in the paid version, you get monitoring, role-based access control, logging, and other stuff. So we need to work around those. So this was the first piece of the puzzle. The gateway nodes and its supporting nodes are up there. Next up, the identity provider. The requirements here are that we want to have several tenants, one for external clients, one for internal on behalf of services, one for system-to-system clients, and so on. And also it should be possible to have different people administering the different tenants. So some kind of role-based access control. But basically the requirements are the usual. For the IDP, we have chosen Keycloak, and that's actually mainly because our people have worked with it previously and found it to suit our needs. Keycloak is a well-known CNCF, or Cloud Native Computing Foundation project, which is backed by Red Hat. Free alternatives, other free alternatives exist, such as WSO2 and APIscene. And of course, there are paid for versions as well, like Okta, but we found that we could hit the ground running with this one. Using this setup, we can isolate the identifying part when an API is called. We can do OAuth, basic auth, bearer auth, and of course, unauthenticated if needed. Using Node-RED Keycloak pair, we are creating JOTs for each call. All the authorization information goes into the JOT, and the call thereby carries its own authorization. What are the reflections on this one then? Well, Keycloak, as I guess any ADP, is hard to learn, but once you master it, then it's a gold mine of goodies. Configuration, it's not easy, nor actually not stable. We need to redo the configuration at each new version. It still seems to be a product under some development, which is actually a good thing. We are running the Postgres database, and we have had problems since we at first put a load balancer between the Keycloak and the Postgres. But for some reason, that gave us problems, which we isolated to a component called Agruel, which is a component doing database connection pooling. We don't know why that happened. Now the problem is that Postgres runs in master-slave mode, and for some reason Keycloak wants write access and to the database. We haven't really found out to get it to talk to a read-only mode. So there are some things to it. With this connection pooling, we were able to find the problem thanks to it being open source, so we could read the source and see where it had the problems. So open source and logging gave us the clues to that. And actually, to be honest, if we would go paid on one of our components, it would be the IDP. The IDP is where you store the keys to the kingdom, and that should not be taken lightly. So if you're setting up something similar, either invest in the competence or go for a paid version. So now that we have added Keycloak part to the puzzle, so there are all the other alternatives as well for Keycloak. To use, instead of using Postgres, you could use MariaDB or something else. But this is the combination we have chosen. Given these two components, we can create an API infrastructure which helps us achieve another goal, zero trust. In a call to the API gateway, the caller authenticates itself. This could be through a variety of method standards, but we have chosen basic auth over TLS or MTLS even. The API gateway then gets the JOT from Keycloak, and we've written a custom plugin in API 6 for getting this JOT, allowing us to do some additional tricks in the API gateway based on attributes for the client that we need. The JOT then, as per standard, includes the roles assigned to the client, but actually no information about the client. And since the JOT does not carry information about the calling client, we are achieving 100% decoupling between the caller and the service. So the call is then forwarded to the upstream service together with the JOT from the Keycloak. The upstream service gets a cert from Keycloak, which is caches, of course, so it can verify the JOT. As a security measure, the connection between API 6 and Keycloak is secured by mutual TLS. Comments on this one. This is okay when the number of roles is not that big. It is the role management that I think will be the challenge for us, and the management of especially the system users. One idea is to have all those set up in a repo somewhere and then to deploy those into Keycloak by CI/CD, making Keycloak more or less headless for at least those realms that are involved. Also, the setup allows for multiple IDPs. So for other scenarios or other types of IDPs, we might need other IDPs, such as OpenFGA or something. Right, next component, the event streaming platform. Here we wanted something for our event streaming, and the requirements was to have some persistence so we could guarantee at least one mode of delivery and also to be able to replay streams. But basically, again, the requirements are the usual. We started out actually with the Apache Pulsar, but never got that really to work. Pulsar was a bit too new maybe, but because it still appeared to have some baby wrinkles. After a lot of trial and error, we changed to NATS, also a CNCF project. This is really where the open source shines. Yes, we needed to change some configuration files and some interfacing components, but it was doable. And there was no contract making us spend a lot of money for a product that we had abandoned. NATS is, if you read, a plain messaging platform, but it has an add-on called Jetstream, which is managing the persistence in the streams. Reflections about this one. NATS is complex. And NATS is not Kafka. Everyone knows Kafka, and NATS is similar, but there are some obvious and some subtle differences, and you have to know those. Now for the final part, the Swiss Army knife, or actually not the Swiss Army knife, but almost. We need a tool that lets us manipulate data. Remember the 3 use cases in the beginning? We need to have the ability to get client data and modify it according to our needs. At the same time, we need to have it function in our operations. It needs to cooperate with the operational tools that we have surrounding it. The requirements are, apart from the usual, ease of use to create integrations. You should really not require a PhD or something in order to create those. It should be maintainable, so updating or managing existing integrations should be easy. It must also be extendable. We want to be able to add parts we need, such as integrations to our logging tools, part of our backend systems, our legacy systems, and so on. So what did we find? We found something called Node-RED. Node-RED is a local tool that originates from the IoT world, which is apparent when you open the app. There's a lot of MQTT stuff in there. I guess that also that some of you have automated things in your homes or so with Node-RED. But it also includes a wealth of other good stuff. The most important one being JSONata, which is a package that lets you easily modify JSON data. We are using that a lot in our translations. Node-RED is a message-based system, as you'd think, since it's built on top of Node.js. We use the messaging part as the flow engine for coding the integrations. Node-RED node system provides us with the data flow, and JSONata in it provides an easy way to transform messages. Other good points about this is that it has Git out of the box with good merge support. And it can use Keycloak for IDP, so we can control access to it. And on that note, we extended the plugin in Node-RED for Keycloak so that we can give access to individual Node-RED pods. Something doable if you're running open source. Are there any challenges? Yes, there is one. It runs on Node.js, and Node.js is single-threaded. So we might hit some roof sometime. But the good thing is that we can have a farm of Node-REDs since we are running it stateless. Okay, next part. The puzzle is complete. We have our API 6 as our API gateway. We have Keycloak as our IDP. We have NATS as our event streaming, and Node-RED for our data integration. And also you can see that we have HashiCorp Vault community. It's a secrets database, so we can store secrets in Node-RED. For instance, connection securities to NATS and to our backend systems. We are using the community versions of the commercial HashiCorp Vault, which is available on GitHub, licensed under the MariaDB license. What do we want to do next? We are currently looking at components for creating reports. Node-RED can do that, but we'd like something a bit simpler for report generation, such as a report generation tool. Smiley. But before going there, we have to up our internal APIs. Well, I know there's no such thing as internal API, but anyways. So these need to expose the data we need for reports. We also need to improve our operations. One very important thing is to monitor your systems. And we are doing some automated logging with warnings if something goes wrong, and we need a tool for that. So for instance, we are looking at Grafana Loki for logging data on the inside. This is so we don't expose GDPR data. Apart from that, we are doing morning rounds, checking that all logs look as they normally do, the CPU meters don't max out, and such. How about interconnecting all these components? Well, an important part to note is that all the interfaces between these nodes are using common standards. Most parts communicate using REST APIs, OAuth, YOTS, JSON, or JDBC for the keycloak to Postgres, and all the APIs are documented. So final notes on this. We are currently transitioning from Docker to Kubernetes, mainly because that's the company's chosen platform. We are running this now on virtual hosts using Docker. It works, but it's a bit of a hassle to set up and update. When we are in the Kubernetes, we'll be well equipped to be in a cloud near you. Same setup, different cloud. But how to run stuff on Kubernetes is a different talk, and that's not an API talk. So that leaves me with 3 final questions. Is it possible to run an integration platform using only open source components? Is it any good? And finally, would I recommend it? And the answer to those questions are yes. Thank you very much for listening.